This video is a very short introduction to direct and inverse proportion. So with direct proportion, as one quantity increases, the other one increases in a direct ratio to that. Now, most commonly we talk about direct proportion as being linear functions such as this, but we can also have the case where the y value can be proportional to, say, x to the power of 4. Right? In that case, what we've got is x to the power of 4 being multiplied by some constant of proportionality, k. The key thing with direct proportion functions is that they pass through the origin. Okay? So both of these are examples of direct proportion. In fact, whenever we have k times x to the power of n and something passing through the origin, we can say that it is direct proportion. Inverse proportion is when one quantity increases and the other one decreases in ratio to that. So this example here is an example of inverse proportion. The key thing with inverse proportion, and this is an example of a graph where y is inversely proportional to x, the cubed root of x, which means that it's some constant of proportionality times 1 over the cubed root of x. With inverse proportion, that's what it looks like. K over x to the power of n, and the key thing that you're looking for is the y-axis is an asymptote for the function. So we'll look at an example that's very well known to you, hopefully, of direct proportion. So we can say that the area of a circle is directly proportional to the square of its radius. So we could write a statement like this, and therefore A is equal to k times r squared. What we need to be able to do to find this relationship between A and r is work out k. So we substitute in the values that we have, and all you need is an x and a y coordinate in order to be able to solve for k. In this case, x and y is r and a. And when you divide this, hopefully you recognize that that constant of proportionality is pi. Once we know that relationship, that a is equal to pi r squared, we can then use that relationship to find values. And rearranging that, we get that r squared is equal to 12 over pi, and r is the square root of 12 over pi, obviously disregarding that negative.